All right, friends, welcome back. Today we are going to talk about linear versus exponential. And you're like, linear, that sounds familiar. Well, I kind of hope it does. Linear is all about that slope intercept, that y equals mx plus b. And if you remember, we would find y equals mx plus b by finding the slope. And the slope was the change in y over the change in x. So I would have to figure out, okay, what am I adding each time? And so in this example, the y is adding by 2 each time, and the x is adding by 1. Remember, and then we do that change in y over change in x. So we would say our slope is 2 over 1. Okay, so that would be 2. And then we would use our b. And our b is right here today. X is 0, 2. So I can write this using everything I know about slope-intercept. But that's for linear. In linear, our y's are adding when we, or I guess it could be subtracting, adding a negative, as we are moving at a constant rate. In exponential, it's a little different. Instead of adding those, we'd be multiplying. So how do I get from 4 to 8? I multiply by 2. How do I get from 8 to 16? I multiply by 2. How do I get from 16 to 32? I multiply by 2. So the difference between linear and exponential when we're looking at them in a table is in linear, our constant is adding, to where in exponential, it's multiplying. So right now, we're just going to look to see if we can tell the difference between a linear and an exponential. So I look here at my x values, and I notice I go from 1 to 2, 2 to 3, 3 to 4. Well, that means that in between each one of these, I look like I am adding 1. Okay. That's constant. But let's look over here. If I go from 8 to 4, well, from 8 to 4, I could be subtracting 4, but I need to be constant. How do I get from 4 to 2? I would be subtracting 2. So that is not linear because I do not have the same change. And so I'm going to look again. What could I do to get from 8 to 4? 8 to 4, what's actually happening here? And I wonder if you're thinking, you're dividing by 2. Yes, but remember, we're not going to be dividing by 2. We're actually going to be multiplying by 1/2. 4 times 1/2 gives me 2. 2 times 1/2 gives me 1. So when we think about it, we might think about it at first as dividing. Well, 8 divided by 2 is 4, but I have to figure out, okay, if I'm dividing by 2, that's just 1 over 2, so I'm multiplying by 1/2. This, though, as we're multiplying each time, tells me that I have exponential equation, or a function here. Let's look at number 2 here. I go from 1 to 2 to 3 to 4. That means I am adding by 1 each time. Now let's look on the other side. I go from 3 to 7. I think I'm adding 4. What about 7 to 11? Yeah, that's still plus 4. What about 11 to 15? That's plus 4. Now because I have a constant that's being added each time, that would be linear. What about number 3? I have -1, 0, 1, 2. Well, I'm adding 1 each time, so I do have a constant here. And then I'm going to look here. How do I get from 12 to 9? Well, I could subtract 3. 9 to 6, subtract 3. 6 to 3, subtract 3. So each time I'm subtracting 3 or adding -3. And since I'm adding, which is what I would be doing for a linear, I say, you know what? This is a linear function. Now let's take a look here at 4. I go from 1 to 0. Well, -1 to 0 is 1. 0 to 1 is 1. And 1 to 2 is 1. And then I get over here and I'm like, 0.125 to 0.5? I don't know. That's just not numbers I think about off the top of my head, right? All right, so if I'm not going to think about it that way, let's think about what numbers am I more comfortable with. If I need to get from 2 to 8, now I could add 6, but this doesn't look like I'm adding 6 each time. So if I wasn't adding 6, I would say, well, 2 to get to 8, I would multiply by 4. We'll go back and check that. If I go from 0.5 and I multiply it by 4, do I get to 2? Double check it. 0.5 times 2. Or 0.5 times 4, does it give 2? Yeah, that does. That's 1/2, 1/2, 1/2, 1/2. Yeah, that's 4. So multiply by 4. And then I have 0.125. Check that out. If I multiply 0.125 times 4, does it get me to 0.5? And the answer is yes. So when you're looking at some of these, especially in exponential is known for using weird fractions and weird decimals, just numbers you don't normally see. Find the one that you're comfortable with and try it out. And then go back and see if it works for your pattern. So each time here I'm multiplying by 4. From 0.125, I multiply by 4, I get 0.5. 0.5 times 4 gives me 2. 2 times 4 gives me 8. That means I have an exponential function. So again, linear, we're adding that constant. It could be positive, it could be negative, but we're adding it. To where exponential, we're actually going to be multiplying.